All right, in this video we're discussing factoring polynomials. We're going to look at 3 examples. Let's talk about the steps first to factoring polynomials. Loosely here I have a set of steps that you can look at just as a refresher or a reminder of what you're supposed to do here in these problems. In step 1, you should factor out your greatest common factor. That's always the first thing you do before you do any other factoring technique. In step 2, you're going to look at the number of terms the polynomial has, and based on the number of terms that it has, you're going to apply a particular technique of factoring. So in the case of 2 terms, you're looking basically for special products. That would be something like the difference of squares, or the sum or difference of cubes. If you're looking at 3 terms, you're basically looking at factoring trinomials, and you're talking about something that's pretty much akin to trial and error. And then if you have a 4-term polynomial, you factor by grouping. All right, so with that in mind, let's go ahead and factor these 3 polynomials. All right, so remember, factoring just means to express as a product. So we want to express the polynomial in example A as a product. Before we do anything else, we have to look for a greatest common factor. Is there anything that's common to both terms? So these 2 terms, is there anything they both have in common? Well, if you think about the fact that 9 can go into 9 1 time and also into 27 3 times, we can say that it has 9 in common, right? So what I'm going to do here is I'm simply going to divide out the 9 from each term of the problem. So if we divide 9x by 9, we'll be just left with x, right? And then we have a minus sign, and then 27 divided by 9 is going to end up giving us 3. So the factoring is 9x minus 3. You can't go any further here because the x minus 3 piece, this piece here, is basically prime. There's nothing we can do to make it any simpler than it already is. So we've expressed it as a product, and the product does multiply back to give you 9x minus 27, so we've factored this polynomial. Okay, let's look at the next one in the list. For the next one, again, before we try any factoring technique, we need to think about the greatest common factor. So is there something that's common to each of the terms? Well, we have 3 terms there, and I think they're all divisible by 5. I believe that each of them can be divided by 5 evenly. Now, also see that every term here has an x value, right? They all have at least one x. So let's take out an x as well. And then it looks like as if they all have a y as well, right? You see each term has a y, at least one y. So we should be able to take out a y also. All right, what's going to be left over if we do that? Well, from the first term, if we take out a 5, the 5 is gone. From x squared, if we take out an x, we'll just end up having 1x left over. If we take out a y will be gone. So for the first term, all that'll be left standing is the x. All right, for the second term, if I take out a 5, the 5 will be gone. If I take out an x, the x will be gone. If I take out one of the y's, I'll only have 1 left over. So we'll have a negative y left over in that case. All right, from there, if I take out a 5 from 75, that actually go in evenly 15 times. And then if we take an x out, we lose the x. If we take a y out, we lose the y. So we end up with just 15 at the end of all this. All right, so this trinomial cannot be factored any further, so we're going to go ahead and declare this fully factored. Okay, let's look at our last example then. Remember, the first step is always to look for a greatest common factor. Do you see anything that's common to both terms? Well, certainly they both have an x, right? Each term has an x here. They also both have a 6 in common, because 6 will go into 12 evenly, and it'll go into 18 evenly. All right, let's look at what happens when we pull out 6x from both terms. All right, so if I divide the 12 by 6, I'm left with just 2. And if I take one of the x's out, I won't have x squared, I'll just have x remaining. So that means we'll have 2x left over after pulling out the 6x. Then we'll take the negative sign with us. 6 goes into 18 evenly 3 times. If we take out an x, we lose that x there, leaving just 3 left over. All right, so that is our factored polynomial. The 2x minus 3 cannot be factored any further, so we're finished.